Good morning, good evening, or good afternoon. Welcome to our webinar on the Cloud Native Journey. My name is Peter Humphrey. I work at Pivotal as a Product Marketing Manager for Cloud Foundry Java Development. And I am joined by my esteemed colleague, Matt Stine, who will be your presenter today. Matt is the Product Manager for Spring Cloud Services for Pivotal Cloud Foundry. For those of you maybe unfamiliar with that beta product, it is the ability to provision certain Netflix open source services, the runtime pieces like Eureka, Hystrix, Turbine, and configuration services as Pivotal Cloud Foundry tiles, allowing you to install, configure, and manage Netflix open source very easily on a distributed platform, cloud native platform like Cloud Foundry. So with that, let's get right to Matt. Matt, would you like to add anything or just jump right on in?
Thanks, Peter. I think I'm going to jump right in just to make sure that we're able to get through this this journey that we're about to go on, because it's going to be a long one and a fun one. So hello.
Let's do it.
And thanks everybody for taking the time to join today. And I want to welcome you to this cloud native journey that we're all on right now. Just a warning up front, this may actually seem a little bit stream of consciousness. The thoughts that went into this presentation, they actually feel a little bit more like a graph, so turning that into something that has a start and an end was a little bit of a challenge. But so if you've read any James Joyce, you know what I'm talking about. If you haven't, don't worry about that. I promise it won't hurt too badly. So what I'd like to do is start by telling you a little bit about my personal cloud native journey. I spent my first 11 years as an application developer, later transitioned into an architect role. And eventually, somewhere along the way, I figured out that my job wasn't just about cutting code, but about the ability to deliver things and actually keep them running. And so I got interested in this thing called DevOps. I had the benefit of not really growing up around a strong operational discipline. And so it really forced me to feel the pain of what it looks like to try to deploy code and keep code running without that DevOps structure in place. A little bit later, I was hired by VMware. Now, presumably they hired me to do application development consulting, but somewhere somebody heard that I could speak Puppet. And I ended up getting sucked into building a private cloud platform for a customer for about 15 months. And I took that experience as I transitioned into being a part of the Cloud Foundry product engineering team. And I've spent about 18 months there helping customers succeed with Pivotal's cloud platform. And along the way of doing that, I got sucked up into this microservices tornado that we see spinning around right now. And a little bit later, transitioned again. I've now spent the last 9-10 months or so as part of the Spring team, helping align Spring and Cloud Foundry around this shared journey to cloud native land, which incidentally I actually wrote a little book about. And so you can get free copies of that through the Pivotal website. I have a bit.ly link there to make that easier. And you fill out a quick form and you can get it in PDF or EPUB or Kindle, whatever your format of choice happens to be. So we started this journey a few years ago, and Mark Andreessen made this movement-defining statement that software is eating the world. Well, that was a few years ago. It's now become absolutely clear that software has, in fact, already eaten the world. So Gartner recently announced some pretty telling observations, including the fact that 45% of the IT organizations that they surveyed have prioritized this idea of application modernization. And then they went on to predict that by 2020, 75% of money that is spent supporting digital business will not be on buying ready-made software, but will in fact be on building new differentiating software specifically to support that business. So what that really tells us then is that the ability to deliver software is really no longer a differentiator. In fact, it's a basic requirement for survival. The companies that embrace these cloud-native patterns of software delivery are going to be the ones that survive. And the companies that don't will not. And the battle is actually going to be fought amongst the cloud-native companies. And what differentiates them will actually be not how they deliver software, but in the digital experiences that they're able to create for their users. And so if that's true, then what is it that these so-called cloud-native unicorn companies are actually doing? Well, I decided to go on a quest to understand these companies, how they operate, and I've essentially come up with 4 key patterns. So you have speed, you have safety, you have scale, and then what I'm now starting to call ubiquity. I used to call this mobility, but what I'm really trying to highlight is not so much the fact that people are interacting from a mobile device. It's that anybody, anywhere, can at any time interact with the services that you're providing. So it's not really the form factor so much as it is the fact that people are able to interact with you in that way. Yesterday it was a phone, today it's a watch. What's it going to be tomorrow? We really don't know. So go back to the top of this stack. Speed is fairly obvious, right? We can innovate, we can experiment, we can deliver value quickly. We want to be able to do that, but we want to be able to do that without breaking things. And so safety balances speed with the simultaneous ability to maintain things like stability and availability and durability. We've often thought that you can't have both of those at the same time, and yet one of the hallmarks of these cloud-native companies is that they do actually have both of those at the same time. And then scale refers to our ability to elastically respond to changes in demand. Demand goes up and down. We want to be able to scale our capacity to meet that demand up and down. Now, part of how we get these things is that the cloud natives practice this thing called continuous delivery. Well, what does that mean? Well, it may help to actually invert the phrase. So instead of continuous delivery, maybe we say delivery continuous, or perhaps if we fix the grammar a bit here, deliver continuously. You see, it's not enough just to deploy something. That's just day one. You also have to deploy again and again and again. And when you do that, you can't break stuff. And that's the day 2 story and the day 3 story and the day 4 story. So as it turns out, operational discipline is actually one of the primary keys to being cloud native. So if you think about this, if it costs you anything to run something, then on some scale of time, the operational cost of that software is going to dwarf the creation cost of that software. And if that operational cost is high, then that day comes even quicker. So if you look at deployment and you look at what is your fixed cost of deployment and you find out that that number's high, what ends up happening is that you spend all of your money and then you don't have any money to actually fund development projects anymore. So we have to be able to operate efficiently to be able to do this. Well, if we're able to continuously deliver, then what are we continuously delivering? So this is where microservices enters the story. Well, what are microservices? There's a lot of bad definitions out there. There are a few good ones. This happens to be Adrian Crowcroft, the former chief cloud architect at Netflix, his definition. And I like his definition, first of all, because it retains the attachment to the past of how we used to describe service-oriented architecture. Now, service-oriented architecture has gotten a bit of a bad name. And a lot of that is not related to the fact that SOA is, in fact, a bad thing. It's that the implementations have very often been not optimal. So if you go read some of the early principle documents around the proposition, the value that people were pitching around service-oriented architecture, that's very much in line with what microservices are trying to do today. The difference is in how service-oriented architecture ends up being bookended in its definition. So on the left, you have this idea of loose coupling. And so we have to be very precise in how we define loose coupling. Well, loose coupling here, again, is tied back to the idea of deployment or delivery, meaning that I can deploy or deliver new versions of any service in my architecture without coordinating with the other teams and services in my architecture before I can do that. Now, obviously, that carries with it the idea that I have to maintain my existing contracts with other services in the ecosystem that depend on me. But as long as I can prove that I do that, then I can deliver anytime I want. Now, that sounds hard, and it is hard, but you have to agree that if you could achieve that, that would be an incredibly powerful tool. Now, one of the ways that you can help to achieve that is through this idea of bounded context, or truly understanding the boundaries around different subcomponents of a system. Now, bounded context is a term that we borrow from Eric Evans' book, Domain-Driven Design, and that was published around 12 years ago when we weren't even talking about microservices, and maybe we were barely talking about this idea of service-oriented architecture. But it's actually much more related to the idea of the business domain and how we model information in that domain. And this idea that certain concepts that we use to describe information, they can't actually have agreed upon meanings by everyone in the organization. And so Evans would tell us to actually embrace that and protect those differing definitions by explicitly protecting them within the scope of a bounded context that has an API that explicitly tells us what we can know about that concept and how we can interact with that concept. Now, if we do this well, we can deliver microservices, but then we have a new problem. You end up building these huge distributed systems. And if you spend any time with those, you know that the probability of any part of the system failing increases exponentially with the number of nodes in the system. And so as we build more nodes, as we build more microservices, over time, the probability that something is failing right now actually starts to approach 100%. And so we end up with this tension between microservices enabling us to deliver faster and scale independently, but then also making it more likely that something in the system is going to fail. And so we have to figure out, how do we build reliable systems from unreliable components? Now, when we look at what we have and we look at cloud native, sometimes we don't understand how we can get there. And we're going to need a system that can do this and take care of this problem and deal with this challenge and maybe some of this over here and a little of that. And we sort of end up like this guy here, just confused and not really knowing, where it is that we need to go and how we can get there. And maybe part of that stems from the fact that we've tried this sort of thing before. Maybe you've tried to take one or more legacy applications and shove them into a Docker container and forklift them into some cloud. It's an incredibly hard problem to solve. And primarily it's because of implicit, poorly understood, and complicated contracts between components. And we'll talk more about contracts a little bit later. But what should be painfully obvious by now is that we cannot try to build and run microservices the same way we built and ran the applications that we now call legacy. That's going to kill you. So what do we do? Well, I'd like to start first with what you should not do. So cloud native does not mean go build a massive DevOps team and then tell them to go configure all the infrastructure and orchestrate all of the containers and compose the distributed systems and generally support any kind of ad hoc general purpose automation that you might dream up, like configuring load balancers or creating NFS mounts. I think my partner in crime, Andrew Clay Schaefer, said it best: ad hoc automation is actually a problem masquerading as a solution. Great job provisioning servers this year. Wait for it. Said no CIO ever. And I know we're really excited about these things called containers now, but the CIO isn't going to congratulate you for orchestrating containers either. That is not the thing that actually delivers the value to the business. That is a means to an end. Okay, so maybe ad hoc automation is not the right path. Perhaps we'll go build our own platform then. Now, other smart people have obviously already built these, but those are the web unicorns. We're the enterprise, and we need an enterprise cloud. We're different from the web unicorns. We have special needs, and we know best how to translate the operational characteristics of the cloud into our world. Now, never mind that we've never built anything like this before, but our cloud is going to let us customize everything to meet the unique needs of our enterprise applications. Now, I've gone down this road personally twice, and the first platform that I built was fairly domain specific. Its job was to support building and running laboratory management systems, and everybody knew it was going to be awesome, but unfortunately, it took 3 years before it ever saw a production application actually running on it. The second platform that I worked on was fairly opinionated general purpose platform that was stitched together from so-called best of breed components. It took 2 years before it saw a production application. So at this rate, maybe if I do it just 2 more times, I'll get to where I want to go. So at this point, I regret to inform you, but you're actually not that smart. You're not that different. You're not special. And I'm actually talking to myself here. When I built that first platform, I thought I had special knowledge. But in hindsight, as it turns out, my needs were actually not significantly different from the web company's needs in any way. And where they were different, they weren't actually going to be met by the platform anyway. They were going to be met by some differentiating software that I actually needed to go write. Now, one of the cool things about having the opportunity to work at Pivotal is the breadth of real-world experience that I get to rub shoulders with every day. I get to talk to people all of the time that have built amazing things. You know, people who are around for the birth of Amazon Web Services, people who've spent time at Netflix and Square and at Twitter. And so I asked them, hey, what's the ratio of developers that are working on real business-facing applications versus developers who are working on platform building? And across the board, the answers are within some small delta of 10 to 1. 10 to 1. The overwhelming majority of developers are not building platforms. They're building apps. And interestingly enough, as I start to reflect back on the 2 platforms that I helped build, the ratio was much the same. But one thing that was true was, where were the strongest, most talented, most experienced developers working? They were working on the platform. They weren't working on the business-facing apps. And so the real question becomes, where do you want your best engineers spending their time? Do you want them solving the problems of delivery, or do you actually want them delivering great software? Ultimately, the degree to which you actually expend human capital on building delivery platforms is a prime indicator of how likely it is you're going to fail. So I want to spend the rest of the time talking about an opinionated platform, a structured platform, which in my mind is really the only way you can achieve this level of effectiveness, because it destroys the need to perform all this undifferentiated heavy lifting. We said the cloud-native companies, they're not going to be differentiated in the way that they deliver software. They're all going to be delivering software in much the same way. And so we don't need to be focusing on that. So this platform takes away the undifferentiated heavy lifting and simultaneously gives you those capabilities that you need to continuously deliver those digital experiences at scale and at speed that your customers have come to depend on. So don't waste time figuring out the structure for your platform. Take all of that brain power that you have and focus that on differentiation, because it turns out that's what your competition is actually going to be doing. So to do that, I want to switch tracks a little bit and explore what maybe at first glance looks like a strange topic for a presentation like this. I've spent some time over the last year playing around with some classes offered by the Complexity Explorer at the Santa Fe Institute. Now, why would I do that? Well, as it turns out, building complex systems is what we do. So it would be interesting to take some complexity theory and apply it to my work. And during that time of studying and relating that back to what I've been working on, I've discovered this path, that if you build systems based on simple rules with commodity components and you have explicit contracts between those components, you can actually build some pretty complex behavior without some massive centralized brain that's running the whole thing. Now, one of the first things that you look at in the Complexity Explorer's classes is the behavior of ants. Now, ants are able to do pretty amazing things, from constructing very complex, intricate structures in their colonies to building bridges out of their own bodies to allow ants to travel across gaps, to even building rafts from their bodies that form this Gore-Tex-like structure that actually repels water and are incredibly difficult to sink. So if we look back at those simple rules, ants, when they're building colonies, they're essentially following the simple rule of grab the piece of dirt that has the most pheromone on it. Ants will secrete these chemicals called pheromone, and they'll walk around randomly picking up dirt. The dirt that they pick is the dirt that's already had pheromone dropped on it. And so they'll pick that up, they'll carry it to the spot that has the other pheromone, and this actually is what turns into this swarming behavior of building these complex structures. When they're building a bridge, the ant comes to the edge, comes to a gap, and says, I'm going to start building a bridge. The next ant shows up, says, I see an ant building a bridge. I'm going to join the bridge. And they continue that until they get to the other side. The ant comes across and sees, okay, the bridge is built, goes to the other side. All the ants cross, no more ants are coming. The ants start taking apart the bridge. The ants fall into water. An ant finds another ant, attaches to it. An ant finds another ant attached to an ant, attaches to that. Eventually a small platform shows up. The ants start walking around randomly on the platform until they find the edge. They attach to the edge until all of the ants have formed this raft. So very simple rules, but very powerful, complicated structures get built. Commodity components, well, we have thousands of ants. Not hard to find ants. The ants come pretty cheap these days. Explicit contracts, well, these contracts are actually hardwired into the brain. I'm not having to teach these ants how to follow these rules in much the same way that once I've hardwired the rules into the software, it just sort of obeys those rules. And so I end up getting this complex behavior of colony building and bridge building and raft building. So the question then becomes, well, hey, what if our platform actually worked that way? Well, as it turns out, some platforms do work that way. So if you go back in a little bit of history of Amazon, Amazon started with very simple rules. And these rules come from the era of actually provisioning physical hardware with the agreement that said hardware would be available 5 minutes after you file a ticket. So I file a ticket, I need a server. 5 minutes later, there's a physical server racked and running that I can interact with. Now, in order to do that, Amazon had anywhere from 3 to 5 different server builds, basically T-shirt sizes. And you were allowed 0 deviation, 0 customization over and above those configurations. And if your software didn't fit into one of those configurations, you were basically told your software is broken. Now, another way to say that is platform is OMAKASE. It should be a meal consisting of dishes selected by the chef. Who's the chef? The chef is the builder of the platform. And so I'd like to talk about the platform that we've built at Pivotal. So starting at the top of the stack and working my way through all the different interesting layers, I want to start with Spring Boot. Now, if you're familiar with Spring, you know Spring has been around a long time. And the amount of boilerplate work involved in the dependency management and initial configuration of a new Spring application for many years was a lot of work. If you could have the luck of landing on a Spring app to work on that had already made it through that phase, Spring made your life very easy, but getting started, not so much. And so one of the things that's happened in the last 3 years is the Spring team has taken years of knowledge of how to best manage dependencies and how to best perform that boilerplate configuration, and taken those strong opinions and baked them directly into the framework. And so now you go to a website like start.spring.io, you plug in your Maven coordinates, you tell it what version of Java, what build system, Maven or Gradle, what version of Spring Boot you want to run with, and then check off a bunch of boxes indicating which components you want. Click a button and you get a zip file that contains the dependency management and boilerplate configuration pushed down into the bits of the framework. And so what you get is an application that's immediately runnable, that you can start writing code in immediately, code not that just makes the application run, but the code that will actually make you money. Boot goes further to take away the idea of, well, what application server container should I actually run this application in, by giving you the ability to easily embed application containers like Tomcat or Jetty or Undertow into an executable jar file. And then it goes even further by baking not just functional concerns into the app, but also production-ready concerns into the app, giving you introspection endpoints that allow you to easily look at application traces and thread dumps and application metrics and application health indicators, all automatically configured. And so what these allow you then to build are applications that are very consistent with the idea of the principles codified in the 12-factor application, something that I'm going to talk about a little bit later when I get into contracts. So this would allow me to very easily build my individual microservices. But then how do I take those individual microservices and compose them? Well, when you start building these distributed systems, you run into a lot of additional challenges. And as it turns out, we have years of distributed systems research that gives us patterns that show us how to solve those problems. Patterns like configuration management and service discovery and client-side routing and load balancing and fault tolerance patterns like circuit breakers and monitoring. And there are many existing implementations of these floating around in the open source space right now. One of the most famous of those are the Netflix tools like Eureka and Hystrix and Ribbon and Zool and so forth. Now, the delta between you cloning Netflix's GitHub repository and actually having a production-ready service that you feel comfortable operating is actually quite large. So what Spring decided to do is what Spring has always done, which is take that complexity and simplify it for the enterprise developer who doesn't have time to fight that complexity. And so using the same programming model familiar to Spring developers, using the same auto-configuration techniques found in Spring Boot, the team has now taken things like Netflix and the HashiCorp stack and Zipkin for distributed systems tracing, Zookeeper, and baked those into a set of implementation agnostic abstractions that are now built into what we call Spring Cloud. Some application workloads have special requirements. So easy for me to take a Spring Boot application, just build a web app. REST API, JSON, wire transfer of data. Take Spring Cloud, do some service discovery, wire those things up. But then you start to think, well, how do I do message-driven microservices? How do I configure batch jobs? How do I do things like stream data processing? Well, as it turns out, those are all just special cases of things that Spring Boot and Spring Cloud already do well. And so Spring Cloud Dataflow takes those components and builds on top of that further opinionated foundation for wiring together individual microservices that are processing streams of messages and taking those components and creating streams or batch flows or just loosely coupled message-driven structures. But at the same time, all of those applications are still just Spring Boot and Spring Cloud applications, and so we don't lose any of the loose coupling and ease of deployment that we have there, but we get this additional benefit on top of that. Now, all of these Spring components, of course, they fit together into this platform that's built on a foundation of battle-tested components for web and data and integration and batch workloads, all built on the mature and trusted core of the Spring framework. And so then you take all of that and you carry it over to the platform runtime itself, which brings its own strong opinions from the infrastructure layer all the way up, including how best to orchestrate infrastructure as a service clouds to deploy and update and manage the health of the platform itself, all the way up to elastically managing the lifecycle of your apps and their backing services. And along the way, we've built this hand-in-glove relationship between the Spring Application Framework platform and the pivotal Cloud Foundry Elastic Runtime platform. And so now as we move into 2016, we're able to leverage all of these strong opinions to create additional value, such as application metrics. So what you see here is our first working internal version of tooling that leverages the fact that all traffic is flowing through the Cloud Foundry router to produce success and error request counts along with latency measurements. And over time, this is going to expand to include container metrics and Spring Boot metrics and distributed tracing data and eventually any arbitrary metrics that an application would want to expose simply by shipping those metrics to a well-known endpoint within its container. And then also continuous integration and delivery pipelines. Many of our customers have asked us to provide opinionated solutions around the entire life cycle of an application, from source control all the way to deployment. Over the last year, we've worked with our partners to bring industry leaders like GitLab and JFrog and CloudBees together for an integrated experience on the pivotal Cloud Foundry platform. Our vision is to create a push-button approach to starting new applications, where you would start from a website like start.spring.io, except instead of stopping at a template Spring Boot application that's further checked into source control and a continuous integration pipeline is automatically created that runs tests, that delivers artifacts to a repository, and deploys that application to Cloud Foundry. So that's where we're going. So if your software doesn't fit into this platform, then your software is probably broken. Now, one of the first questions that I get at this point is often around the idea of polyglot programming. Isn't one of the promises of microservices that everyone can write their services in whatever languages that they choose? Well, sure, but I actually think that polyglot programming is a red herring here. Polyglot is not the thing that makes you cloud native. Polyglot actually makes it harder to enforce the simple rules and the explicit contracts that make the platform so powerful. Is it impossible? No. Will Cloud Foundry always support multiple languages? Absolutely. But there's definitely a cost to providing the same OMAKASE experience with every taste in programming language. So let's look back at the four things again and find them in this platform. So if you start to think about simple rules, there's a whole list of simple rules that you find. How Spring Boot resolves configuration properties in its environment and how conflicts are resolved. Just the simple finite state machine of the circuit breaker pattern itself. How Eureka provides fault-tolerant service discovery by caching the service registry locally and then performing all lookups against the cache. How the Cloud Foundry build packs go through this detect, compile, and upload process to go from here is my code to a runnable container environment. How the Java build pack uses heuristics to calculate JVM memory settings. How the Cloud Foundry runtime abstracts deployment of applications to the basics of long-running processes and completable tasks. How the entire platform accomplishes deployment and scaling and health monitoring through the continual convergence of desired and actual state. How logs that are only written to standard out and standard error are actually aggregated into a single stream that's filterable by any desired dimension. And how the front-end routing table is continually updated as the actual state of the platform changes. All of these different areas are driven by very simple rules that you can understand easily, but then when you combine them, create this very complicated and powerful behavior. Well, how about contracts? Well, every layer of the stack has an explicit contract with the layer immediately beneath it. So I already mentioned 12-factor applications. This idea of declarative configuration and stateless shared nothing processes and loose coupling to the environment. Those patterns can be used to create apps, but if those apps aren't written to run on a 12-factor platform, then it's probably not going to work out very well. So 12-factor describes the relationship between an application and the substrate on which it's running. Well, where does that substrate or that runtime platform come from? Well, it is also an application, and that application can be described as a BOSH release and a BOSH deployment manifest. And so we take those two as a contract and we hand them to the BOSH cluster management platform, which then takes that and uses its explicit contract with the infrastructure, which is described through the cloud provider interface. Simple abstraction that talks about things like creating VMs, deleting VMs, creating disks, mounting disks, unmounting disks, deleting disks, and so on, where we have a implementation specific to each of those. But the BOSH code knows nothing about explicit implementations. It knows how to take BOSH releases and BOSH deployments and use the CPI in a generic way to spin up the Cloud Foundry platform in that cloud environment. And so through these contracts, we're able to not only manage and keep workloads running, but then migrate those workloads from place to place without making significant changes. So let's say we have all this. What does a platform then like this allow us to do? Well, first of all, we have to answer the question. We have simple rules. We have explicit contracts. What are our commodity components? Well, this is where the microservices actually come into play. See, it's not the fact that microservices themselves give us the power. It's the fact that the microservices are composed in these very specific ways, following these specific rules that are simple, using these specific and explicit contracts that gives us the power. So what does the platform allow us to do? Well, with your platform needs met, you can then start to focus brain power on dealing with the organizational challenges that you have. Conway said you can't help but reproduce in your architecture the structure of your organization. So now you've freed up your brain to think about, well, where are we organizationally, and where do we need to go organizationally to become cloud native? And you're then able to apply techniques like what ThoughtWorks has described as the inverse Conway maneuver, taking steps like Netflix did earlier in their life cycle. Once you decide the architecture that your system needs to have, you restructure your organization over time to look like that architecture. And then according to Conway, that architecture should simply emerge. And so then you can actually get about the business, now that you're restructured, of building these small teams focused on delivering business capabilities that are building microservices. And those capability teams understand and code and test and deploy and monitor and own the life cycle of those services until they're no longer needed. And they communicate with one another not through ticketing systems, but through APIs that are verifiable with real running code. And then those same microservices interact with their platform not through ticketing systems, but through self-service APIs that allow those microservices to get access to the infrastructure services that they need. And that is the interplay between Spring Boot and Spring Cloud and Spring Cloud Data Flow and Cloud Foundry. But what if you don't have a platform like this? Well, first of all, you're probably going to make some things too complicated, too hard, because you start to think about, well, here's how my problems are special, and here's how I'm different from these other organizations that built these platforms that came before me. And when you do that, you create the need for specialization at multiple levels of your architecture. And those specialists, of course, need places to live, and so you end up staying stuck in or sometimes rebuilding the very silos that you tried to tear down. So we need the platform to remind us of the facts that we discussed earlier, that we're not that smart, we're not different, we're not special. And the platform constrains us to not focus on these ideas and to keep thinking about delivering differentiated software. And then we're able to get back to the business of delivering the thing that actually makes our customers awesome, not the platform, but the software itself, which is in turn what empowers us to win. And so with that, game on. No, I just wanted to thank everybody for coming. And again, if you want to go a little bit deeper into the topic, don't forget that the Migrating to Cloud Native Architectures book that I wrote is freely available on the Pivotal website, and check that out. And feel free to reach out and ask questions and give me any feedback that you have over email, or you can find me on Twitter at mstine.
Awesome. All right. Thanks, everyone. Appreciate your time, and have a great day. Bye-bye.